Hey everybody, this is Larry. So I don't usually do this, but I'm gonna do the explanation first, and then you can watch me solve it live later. In general, for the most part, I know what I'm doing, but this time I actually went. Actually, I still kind of did mostly what I wanted to do, but I did do it way too. I went to a hiccup, so and you could see it, watch it live after this. But yeah, I just want to do the explanation in the beginning. Yeah, hit the like button, hit the subscribe button, join me on Discord, and today we're gonna go over today's poem, majority element, for day 22 of the September Daily Challenge. So the prerequisite that I think you should know is about the Baltimore majority algorithm. There's a link here. I'll link it in the comments, and yeah, and then the idea is that we extend it from going over n over 2 times to n over 3 times. So that's pretty much it. And the idea is basically extending. And when you watch me solve it live, I actually explore some of these ideas and thought process. So I definitely recommend staying for that. If you want to see the live thought process of a problem that I haven't solved, or I don't think I've ever solved this before, so or even seen it before, so it is new to me. But basically the idea is that having two candidates, it's we're gonna go in. So to convert it from n over 2 to n over 3, we use two candidates instead, and having two counts as well instead of one count. And the idea behind boiler more is that you have this kind of majority thing where you just count the number of elements, that in a way you count the delta of the number of elements that's in it, in a candidate, minus the number of votes that is for non-candidates, right? It's a tricky way, and the majority algorithm works only if these elements exist, which is why we do a second scan later. But so how does this generalize to 1/3 instead of 1/2? Well, it starts up the same for when we get a row and it's for a candidate that we already have, then we just increment the row. Otherwise, we kick one of these people out, or we attempt to kick one of these people out, or we just decrement both of them. The key point to notice, and which I didn't during the video, is that this only happens half the time, because it would require both count 1 and count 2 is not 0. So if one of these is 0, that means that that row only counted half the time. So from that, you get that's the only invariant that you need to solve this problem, and then that's how you have the candidates. At the end of this, you would have candidate 1 and 2 in the thing, in the variable, and then you have to do a final loop because you have to assume that they exist, and then you just check that it reaches 1/3. So this is a very short explanation for sure. I go into it a little bit more detail when I solve it live, but I just want to kind of go over the code because it's a longer video today for that reason, and because I made a typo, but I thought the algorithm was wrong, so it happens. And yeah, so the complexity of this will be linear time, because we do all of one work per element. Everything I highlighted is all of 1, and all this is obviously all of 1, so this is going to be all of n times. For complexity, we only have 4 variables, 5 variables, 6 variables, something like that, so constant space as well, which is the requirement that is needed for this. Yeah, as I said, this is not an algorithm that I've seen very often, even in the majority case, let alone the 1/3 case. I don't know what that means, but so you can take it means both on interview or competitive. Yeah, that's all I have. Hit the like button, hit the subscribe button, join me on Discord, and you could watch me actually solving this live next. Hey everybody, this is Larry. This is day 22nd of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord, and let's get solving this problem live. Majority element 2. Okay. I guess it's probably similar to the first one with the boiler Moore algorithm. That's what I'm going to guess. Not gonna lie. So, uh, um, so yeah. So I do solve these live. So sometimes I'm going to run into some hiccups. So bear with me for a second. I don't think I've used this before. Or this problem before. I'm going to put a link here. Just Googled it real quick. But that is the algorithm that you should know as a prerequisite for this. But and you know, I mean, I don't know how practical it is for interviews, but it is just kind of something that I figured I would need. But I haven't know how to solve this before. But my guess is that given that n over 3, you know, by pigeonhole or whatever, at most it's going to have 2 elements, right? Because if similar to because if you have more than 3 elements that appear more than n over 3 times, then you have more than 100%, which is obviously not possible. So from that, we can just maybe keep track of some counter and then figure out what are the possible ones. So I'm not gonna lie, for this problem, I haven't thought this through, and I haven't seen this a similar problem before, other than knowing that it's boiling more. So, and I'm not that practiced on this problem. So bear with me, and let's kind of work through it together. That'll be a fun challenge for today. So let's go through it. So for x in nums, so okay, so how would I think about this? Right, so on the 2 people boiler Moore algorithm, if I remember correctly, and hopefully I do, otherwise, otherwise something will be tricky. Is that basically you're trying to find the delta of one element and everything else, right? So yeah, so and what I mean by that is that and some of this is pigeonhole, but basically, let's say you have and I'm just explaining the 2 people or two element or majority version, which is n over 2 version, which is that if you have something that, you know, let's say you have 15 elements, right? What you're looking for is something that appears 8 times. So that means that if it appears 8 times, then or more, then you have a candidate that has that will end up with +1 at the end, right? Because it shows up 8 times and so forth. So yeah, so I think that's what I'm gonna do with a similar method of, but it can instead of doing 1 candidate, I'm gonna have 2 candidates, and yeah, I think the thing I have to think about that I'm a little bit hung up on right now is just figuring out what happens when you find an element that isn't one of the 2 candidates, right? So basically, you have candidate. Let's say you have the first candidate, candidate 1. You have candidate 2. Let's say you have something that appears like some random x, right? Do you decrement from the first one and the second one, or just the first one, or just the second one, right? Well, you know that if x appears, what that means is that okay, well, maybe it'll be easier if I work out a case. So basically, let's say we have 15 elements or 15 votes, right? Let's say candidate 1 already have 4 votes and candidate 2 already have 2 votes, right? Let's say now you're voting for a third candidate, Larry, or I don't know. Then what does that mean? That means that in order for candidate 1 to have 1/3 of the vote, it would decrement by 1, and so is this one. Is that reasonable? I don't know. I'm gonna play around. So the tricky part for this is just the visualization. It's a very relatively I wouldn't say obscure. It just doesn't come up that often, this algorithm, even in competitive. So the visualization is gonna help. But let's I'm gonna play around with. Sometimes it helps to people have different visualization techniques, and I urge that you find the visualization technique that works best for you. Sometimes I have pen and paper to ready, and that's what I'm going to use. And sometimes I just write very short snippet of code that simulates what I want, and then kind of use print statements or something like that to kind of visualize what that means for me. So I'm gonna let's get started on that. So let's say we have candidates 1 is equal to say none, right? Doesn't really matter. Candidates, well, okay. Candidates 2 is equal to none, count 1 is equal to 0, count 2 is equal to 0, right? So, okay. So, okay. So if count 1 is equal to 0, then we want to assign candidate 1 to x, and then count 1 is equal to 1. I mean, this is just similar to the original for the more majority algorithm. So I'm just writing it out and then kind of visualizing what that means as and try to figure out what the invariant could be, right? Okay. Oh, actually, I have to make sure that it's not one of the candidates yet. Usually, I mean, this is I think this is the order I do it in for for majority for n over 2. But I think that in this case it may not make sense. So, so if this is equal to candidate 1, then count 1 1. Else if candidate 2, you increment by 1. Let's just say, and then just continue, make it easy. And then else, this is a new number, right? So we either put it in, or this is we have to subtract from count 1 and count 2. Okay, is that okay enough? I think this one will be very illustrative. I can't even English right now. It'll show us. It'll help us visualize the most. So yeah. So now we return candidate. Okay. So results is equal to empty list if count 1 is greater than 0. Results dot append candidates 1. If count 2 is greater than 0, results dot append candidates 2, and then just return results. I don't think this. So this is not final. This is not what I click. This is not right yet. Because we still should do a pass to verify that they're the majority or the 1/3 majority. But I just want to see real quick what this gives us. So this gives us 2. Again, that's because of the verification step, right? This looks okay, but I want to see, for visualization, I wanted to see the progression of the states as we go through them. And this one is a little bit tricky to do because we have continuous statements, but we're going to try. Oops. Okay, so yeah, put 1 in there, there's 1 1 2 3, and put a 3. Okay, 3 1 3 2, and then now we see a 2 goes to 2 0, and then now 2 overtakes. To be honest, I'm not that confident about it, even though this seems okay. So let's go do a for loop again for x in nums. If x is equal to candidates 1, let's reset the count real quick. I think that should be okay. And then we just verify that if now in this case instead of greater than 0 is n over 3 4 exactly, right? So let's just say target and then we'll do the math. Nums. Okay, so this gives us okay. So let's so usually so in a normal setting I'm going to play around with more different test cases. Let's actually do that real quick. But for the most part, yeah, I'm going to try to think through different scenarios, different ordering of the stuff. But in the interest of time, I'm just going to submit just to kind of see how that goes. So yeah, I didn't actually click on submit that one, but okay. So I'm going to submit, and if we get a wrong answer, that's okay, because then now I can see what the situation is. Okay. Because right now I'm still trying to understand the problem, and that's part of the learning. Is that it depends on what you want to practice for, right? If I want to practice for a contest and I want to practice for correctness, then I am going to, just think for these different cases. For now, I'm just practicing learning this thing, so I'm still trying to figure out cases that, in time efficient way, just like what am I doing, right? Hey everybody. So usually this is going to be a live recording, and it was a live recording, but I inserted this kind of quick disclaimer because so apparently what I did was I had a typo, and if you follow it through you'll see it. So I'm going to put a link for you to skip to the end where I explain the complexity and stuff like that, or you could watch me try to solve it, or try other techniques, and try to visualize the problem for the next like 20 minutes. That's my bad. Whoops. Sometimes it happens. Sometimes it happens to the best of us. So I hope that you also learn from that if you like. Anyway, thank you. So okay, so in this case that is very clear why this is my current algorithm is that way, because for the ones it drops off. It drops off because there are enough unique elements, which actually should be the case that I at least try really, really quick. One is clearly the answer, but because we have the 3, 4, 5, 6 will delete the answers from these. So, So I think now now I have to think about how this generalized. So my generalization attempt was not good, or it was not accurate. Now I wonder if we just do it one at a time, because I think the thing we want is that so what does that mean when one non will come in? That means that I'm thinking just in general maybe that I need to double everything. So that's my thought process right now. And why do I say that? And maybe the constant isn't right for doubling, but what I mean is that when a row comes in, what does this do to it, right? So your target needs to be this number of nums over 3, and when a non-row comes in, that means that for every 2 rows that isn't your number, it cancels out your previous row, right? So that's how I would think about it. And from that, was this there? Did I just had a typo? I think maybe this is a typo as well, but so that's actually pretty bad. I don't know if I just noticed it or whatever, but how did that and not all my answers are wrong? Huh? Did I just get really lucky on a typo? Now something's weird. What did I change? How come my answer is really wrong? That's awkward. Well, this should definitely be 1 regardless. But I think now instead of incremented by 1, it should be you go by 2, because every 2 rows that you Oh, sorry, every 1 vote that you get will get cancelled by 2 votes. So that you can actually do +1 for the count of number of votes, and then this is 2 too. And then subtract half every time you get another vote. But just to make it easier, I double everything. That's why I said earlier about doubling. But now I'm returning nothing. Did I have a typo somewhere? Because it was clearly working earlier. Huh. That's weird. Yeah, 4 and 2 votes, that looks good. So that means that stuff should be on this side. For X is none. Do I not set the candidates right? No, it looks okay. Oops. So yeah, so that's kind of my thought process, and some of this, like I said, is about getting the right visualization as you saw through the problem. And for me, you could kind of see like sometimes a wrong answer will just give you right, clear, immediate visualization of, oh yeah, of course this is wrong because the 3 ones will get easily cancelled by 3, 4, and 5, even though that's not enough, right? That obviously still is good. But yeah, let's have a typo somewhere. What's this? These looks good, right? These are good candidates. Also, why does it write candidates 2? It should be candidate 2. Oops. So my grammar is poor too, but Sorry about this debugging. That is really weird. What? I mean, maybe you're sitting at home and you're like, okay, this is clearly whatever, but the target is just wrong. Oh, why did I delete the divided by 3? So okay, I don't know what happened there. Maybe there was a typo somewhere that I did it by accident. But okay, so this looks better, but clearly there's still a wrong answer here. So I have to kind of debug that now. That's weird. So yeah, so 1 and 3 are candidates for some reason. Oh, because now these are no longer 0. Or no, that's not true, right? This has 4. So I guess there is another my algorithm is just wrong. Or it's not complete. I have to think about this a little bit, because basically this gets 4 votes, quote unquote, that gets cancelled by, or rather, there's an invariant that I have to think about, because for these, the 3, they get 4 votes, which in theory these will get cancelled by, but the ones here as well. I think we have to. I'm just thinking about different possibilities of fixing this. And it might be just that, I don't know. Can we do it in parallel? Or do I, maybe I can do it a second time and then just do the majority of the second one? Because we definitely have an algorithm that allows us to get the 1/3 for at least one number. But maybe it doesn't work for two numbers, and then we could get the majority of the remaining numbers, right? Let's do that instead. I think I was trying to be too clever with trying to do one pass. Sorry about that. As I said, this is experimental, so you know, I guess we'll see. But yeah, okay. Let's try to get one number that's 1/3, and if we have one number, that means that we have a possible second number, right? Because if no, I don't. Now I'm not so sure. I mean, I think now with this visualization, I can see how these two votes cancel out these one vote, right? Like 3, 4 cancel out the 1, 1 makes sense, but the way that I did it, the ordering is weird because if I change this to, for example, 3, 4, 5, 6, 1, 1, 1, 1, or similar to this actually, just 3, 3, 2, 2, 2. Like we could do 3. Let's move to 5, 6 to the front. This is a very long video, sorry. But yeah, these 3 will get cancelled by these 4 ones, but we want ones to be the answer. So this is not good enough. Let's revert this real quick. And then now we have to think about another invariant that we can think about. And maybe we just do one at a time. I don't know. Let's play around with that. Sometimes in a contest, you just have to be able to play around with stuff. So because that was one of my alternative things to play around with, but that doesn't seem like it gives you the answer, obviously, because this is clearly not right. Because now the 3, 3, so now 1, and then 2 removes the 1 but not the 3, even though we wanted to remove the 3. Huh. Would greedy work? Now I'm just trying different things, to be honest. And let's click on submit for fun, and then see if we could get a test case that tells us something. Okay, so alternating is a good one. It's basically you have 2, 2, you have 9, 3. Yeah, because then 9, and then the 3 cancels out the 9 because we're greedy, and then 9 comes in again, and then so forth. So 2 is always a candidate. So the last 2 candidates are 2 and 9, but you do the last pass, the 2 will clear this out. So no good there. And then the 9, yeah, this is an interesting problem. You don't want to do it anymore. Now I have to think about it a little bit more. No pun intended. I guess I don't remember this algorithm as well as I hoped. So I'm just looking a little bit on the Wikipedia article, but Let me see what shows up here. Just try to figure out good visualization with this as well. So this one, it looks good on this answer, but also what? Didn't we have a wrong answer somewhere that did I what? How did I look at my submissions? Because these are clearly right, but I had a wrong answer. Was that wrong answer just because I had count 1? So let's submit again, why not? Okay, wow, okay, so my first answer was right. It's just that I had a typo, and I thought that my algorithm was wrong. Okay. Sometimes you just have silly days. Yeah, okay, I don't know what to say about that, but this is, I mean, this is my first intuition, right? And I, like, as I said, you know, gonna go through visualizations, and you know, it makes sense. But yeah, so what is the complexity? So this is going to be linear time. We look at each element at most once, and at most all one time. So it's going to be linear time. And in terms of space, we only have 4 variables really, right? So, and the results, I guess a couple more variables. So it's going to be all one space. Yeah, that's all I have for this problem. Yeah, let me know what you think. I think I'm just a little confused because I had a typo that that kind of messed up this video a little bit, so I apologize for that. And some of it is because maybe as a meta lesson, if you're still here for so long, that that you know, for a lot of problems, I'm confident. And when you're confident, then that means about the algorithm, right? And when you're confident about the algorithm, then you're gonna know that it's the implementation issue, and that might mean a typo, that might mean other things. And in this case, because I was not confident about the algorithm, I didn't think about implementation issue, because that was pretty straightforward implementation wise, but somehow I still had a typo. And yeah, so definitely maybe that's my takeaway for this. Let me know what you think. Hit the like button, hit the subscribe button, join me in Discord, and hopefully tomorrow will be a better day for lead coding, and I will see you tomorrow. Bye bye.